So today is part 2 of day 2 with domain and range, because we're also going to be talking about all of the pieces of what a graph is and all the things, we call them attributes. So part of what attributes of what we're going to cover in Algebra 2 includes domain and range, which is Algebra 1, but also now increasing intervals of increasing and decreasing, and intervals where f of x is positive and negative. So let's talk about all of these things. So intervals where f of x is increasing, decreasing, constant, positive, or negative, those things are always, we don't get to say always a lot, but we've got to say it twice today. It is always going to be intervals of the domain, meaning that you are using the x values. Even though what we are talking about is the y values. We're talking about the y being positive. We're talking about the y going up. But we are talking about the where, so it is the x value. So anytime, really the only thing you're using y for is range. Everything else is your x's. Almost everything. Everything else, y-intercept is going to be your y, okay? But everything else is using your x values, not your y's. Even though what we are talking about is the y's, you're still using your x values. So let's talk about increasing. Well, let's think, what does increasing mean? Increasing means it is going up. Well, what does a graph going up look like? Very simply, a linear graph going up is going to look like this. So let's think about, what is this graph doing? As my x's are increasing, what is happening? Or let's get a little bit more fancy with our words. As my inputs are increasing, what is happening to my outputs? Well, my outputs are also increasing. My y values are also going up. My x's are going up, my y's are going up. Both things are going up. So let's talk about decreasing. A very basic decreasing linear graph is just going to go down. Now, again, let's just start with my inputs are increasing, because that's what they're doing. When you're reading your graph from left to right, your inputs are increasing. So as my inputs are increasing, what is my y values doing, or what are my outputs doing? Well, so here's just a graph or illustration that my x's are increasing, going from left to right, my x's are increasing. What are my outputs doing? My outputs are decreasing now. Now we have f of x is positive and f of x is negative. Now, maybe you remember this from Algebra 1. Maybe this is a whole new thing to you because you just don't remember it at all. But f of x, that's another word for your y, and what we're talking about there is your outputs. So when my outputs are positive, that is what that phrase is looking for, when your output is positive. So what we're looking for there are your output values are above the y-axis. Y-axis is right here, and we're wanting the output values that are above that, meaning that they're positive. They're not a negative value. Your outputs are a positive value. And then when f of x is negative, again, you're talking about your outputs. So your output values are now below the y-axis. And your output values are going to be negative. So your y values are going to be in the negative range. All right, so first example, linear. Super simple. Let's just start with the easy stuff. Domain, again, maybe you need this refresher. Domain is going from left to right. So how far left is this going? Negative infinity. How far right is it going? Positive infinity. We're going to be using interval notation pretty much the rest of the year, unless I tell you otherwise. Interval notation. So interval notation is the stuff with the parentheses and the brackets. Infinities are always going to get parentheses. Your range, low to high. How low does it go? Negative infinity. How high? Positive infinity. Now, as you're reading this from left to right, I draw arrows to show if it's going up or is it going down. So as I'm reading this from left to right, I am drawing arrows that are going up. So where is this increasing? It is increasing everywhere. Not how it is increasing, but where is it increasing? It is increasing on the x value everywhere. So negative infinity to infinity. Where is it decreasing? It's not. So it is NA. Not applicable. It is not decreasing. Now, where is f of x positive? It is positive above the y-axis. So in that little corner right there, that little tiny like triangle piece right there, that is where it is positive. And where is that starting? It is starting at 4. Again, where? Where, not how it is becoming positive. Where is it starting being positive? It is starting at 4. And it's going to go on to forever, so infinity. But let's talk about that 4. That 4, what is that ordered pair at 4? That ordered pair at 4 is 4, 0. Is 0 positive or is 0 negative? It's not either. So 4 is going to get a parenthesis, meaning it is not included in the interval of positiveness, right? It's not positive. It's not negative either. We'll get to that in just a second. But it's not positive. So it's not including. The bracket means that it's including in the interval. Now, I am not saying that 4 is not including, that there's not an ordered pair at 4. There is. I put that in the domain and range. But it is not positive at 4. Now let's talk about where it's negative. Again, I draw some positives where it's positive. I draw some negatives where it's negative. In future slides, I'll also do some highlights on top of all of that. So it's negative. How far left is it negative? Or where does it start being negative? Well, it starts at negative infinity. And where does it stop being negative? It stops being negative at 4. And again, 4 is 0. The output of 4 is 0, and 0 is not positive nor negative, so 4 also on this one gets a parenthesis and not a bracket. So underneath this, I'm just going to add a little piece right here. I'm going to make it kind of look a little bit different in one kind of sentence in here. So at f of 4, which is interval notation, 4 is my input, that's going to equal 0. And since 0 is neither positive nor negative, it is not included in either interval, and so it is going to get parentheses. Usually, your positive and your negatives are going to include parentheses and not brackets. Now, I say usually because it's not an always, okay? So I would say most of the time your intervals are going to get parentheses and not brackets there. There are cases where it is different, and we might see those. All right, so now I have a quadratic graph. Domain, how far left and how far right? Well, this is going forever left and forever right, so negative infinity to positive infinity. How low is this going? This is going as low as -1, and it is going as high as infinity. Now, -1 is going to get a bracket because -1 is included. Okay, it is a solid line. It is including, if it's on the line, I like to say if it's on the line, it gets a line when you're talking inequalities, and if it gets a line, it gets a bracket. Now, where is it increasing? It is increasing. Where is it going uphill? It is going uphill starting at, hopefully you remember that that's called the vertex. It is going uphill from there. So it is starting at 1 and going to infinity. But let's talk about what is happening at that vertex. If you think about this as, usually I talk about inverted ones. Inverted parabolas look like roller coasters. And if you've ever been on a roller coaster and you've ever sat in the front of a roller coaster, it goes up and up and up and up. And when you get to that top, you actually kind of stop and let the back of the people catch up to you, and then it drops you down. So at that very top of that vertex, you're not moving. That does not have a positive slope like the rest of this does. The rest of this right-hand side has a positive slope. The vertex doesn't. The vertex has a solid slope. So that 1 is not included in that interval. Now, where is this decreasing? Where is it going downhill? Well, that's the left side. It is decreasing all over there. And where is that starting its decrease? It's starting at negative infinity and stopping at 1. And again, 1 is not going to get included because your vertex does not have a positive nor a negative slope. It doesn't have either one. So where is it positive? It's positive in two places. Where is it above the y-axis? It's above the y-axis in two places. Now this time I've highlighted it. Highlighting it can really help you understand what you're talking about when you're talking about the positive and the negative. So where is it positive? How far left is it starting the positive? It's starting as far left as negative infinity, and it's stopping at -1. Now because there's two of them, remember we're going to use that mathematical and it is going from 3 to infinity. Now they're at -1 and 3. Those are outputs of zeros, which are not included, which is why they get parentheses and not brackets. Now where is it negative? I can draw negative signs on that bottom half, or I can highlight the negative side. And where is it starting being negative? It's starting being negative at -1, and it is stopping being negative at 3. Now it's only that one interval, so I just have the one interval, -1 to 3. Again, it's not including -1 and 3 because those have outputs of 0. Again, just because it's on a second page, maybe you want to write a couple notes up here at the top that we're using the x values and your vertex is not included in intervals. Now, this is what we call a piecewise function. It has many pieces that are doing different things. It is not one solid function. It is this function to here, and then it's doing this, and then it's doing this, okay? It's got multiple pieces. It could be 2 pieces, it could be 3 pieces, it could be 7 pieces. This is what we call a piecewise function. So domain, I'm going to use my highlighter, and I'm going to start with the left. So how far left am I going? I'm going from -infinity to 4, and that's my first stop. And 4 is open, so -4 is going to get a parenthesis. I have a u. And then I'm going to go from -3, which is it's closed, so it is going to get a bracket. -3 to -1, which also is going to get a bracket. And then it's picking back up again at 0 and going forever right. So that's going to go from 0, which is going to get a bracket, to infinity. Okay? Now I'm going to erase all of that again, all the highlights. And then I'm going to go range, because range goes from low to high. So I'm going to start as low as it goes with the arrow, and then I'm going to go up. So it's going to 0. So my first interval of range is -infinity to 0. Then it's picking back up at 1, and 0 gets a bracket because it's included. It has a closed dot. Then I'm picking back up at 1, but if you notice, because I'm talking range, I don't stop. I have a closed dot connecting to an open dot, and then it's going up. It doesn't stop. There's no jump vertically right there. Not between those two pieces. There's not a jump vertically. There's a jump horizontally, but not vertically. So I don't have a separate interval right there between those two. That is just going from 1 to infinity. Now, let's talk about increasing. Actually, let's just do all the directions. As I'm writing this from left to right, I'm going down first, and then I'm going across, and then I'm going down again. So am I ever increasing? No, I'm never going uphill anywhere. Now, where am I decreasing? I'm decreasing twice. I'm starting my decrease at -infinity and stopping it at -4, and then picking it back up at 0 and going to infinity. Now, where is it constant? It is constant from -3 to -1. Now, let's talk about what it means to be constant. At my ordered pair, constant means it has no slope. So at -3, -3, do I have no slope? Is my slope constant from -3 to -3? Yeah, so -3 is included, and so is -1, because they both have closed dots, and it's a straight line. That's not changing at those end points. So -3 and -1 are included in your interval there. So I've just put a little note down here. Constants can be, not always, constants can be included in your intervals. All right, so let's talk about where it's positive. I'm just going to use the highlighter this time. So where it's positive, it is positive from negative infinity to negative 4. I have a jump in my domain, so I have to include that jump in the domain. So negative infinity to negative 4, and negative 4 is going to get a parenthesis. But it is still positive at negative 3 and negative 1. And those outputs are included. Now, why are those outputs included where the other ones have not been? Because what is my output at negative 3? Negative 3 is positive 1. So negative 3 is positive 1, which is positive, and negative 1 has an output of positive 1, which is positive. Because those are also closed dots, they get to be included in this interval of positivity. Now, where is it negative? It's starting being negative. I'm going to use the highlighter again for the negative pieces. It is starting being negative at 0, but 0, 0 has an output of 0, which is not positive or negative, so 0 is not going to be included. And then it's stopping being negative at infinity. Now, even though this is going to, which I understand, it is going down to negative infinity, the where is talking about the x's. The x's are being positive, which is why it is a positive infinity, not a negative infinity. Even though, yes, it is going down to negative infinity, the where it is happening is a positive infinity. All right, this last one, I would like you to try it. I would like you to try this one on your own. Are you going to make mistakes? Possibly. I also don't want you to miss the fact that there is that solid dot down there. Okay, it's a very easy dot to miss. I don't want you to miss seeing it as you're attempting this. So try this one in pencil in case you make mistakes. Stop the video and then come back and see my explanation. All right, so let's talk domain. Domain, I'm going to start from the left. So got my highlighter going from negative infinity to negative 1. But I'm picking it back up at negative 1 and going to 1. That solid dot is filling in those open dots, and then it's going forever. So this has a domain of negative infinity to infinity. If you need to go back and rewatch that highlighting thing again and see like how all of those jumps happened, okay? But if you look at that, every open dot is then filled in with a closed dot. Everywhere there's an x value with an open dot, there is a closed dot somewhere. So all of my x's are covered. This is all real numbers. So now let's talk about range. How low is it going? It's going as low as the negative infinity because of that arrow. It goes as high as here, and then it can pick back up there and go to infinity. So this also has a range of all real numbers. Every y is covered. There's not a gap in the y's anywhere. Now, where is this increasing? Where is it going uphill? I'm going to draw some arrows through all of this so we can see what's happening. There's where it's going uphill, then it's going downhill, then it's going across, then it is going downhill, and then back going uphill. So where is this increasing? The first one is at negative infinity to negative 2. And again, negative 2, it's not increasing nor decreasing. Vertexes are not included. And then where is it picking back up, increasing again at positive 2 to infinity? Where is it decreasing? I have 2 of those. So it is decreasing from negative 2 to negative 1, picking back up at 1 and going to 2. And where is it constant? It is constant from negative 1 to 1. And those do get brackets. Negative 1 definitely gets a bracket because it's a closed dot at negative 1, 1. But 1, 1 is open. So that's leading me to say it gets a parenthesis. But down there at the bottom, there is a closed dot at 1, which is also a constant. So it is going to get a bracket. Both of those are going to get a bracket because of that dot at the bottom. If that dot at the bottom was not there, you would leave it open. All right. Where is it positive? All of this stuff happening over here is where it is positive. So it is starting being positive at negative 3, and it is stopping at those 2 open dots at 1. So it is stopping being positive at 1 because I don't have that in my interval. It's both open right there at 1. and then I'm picking back up at 1. So right there and there it's positive, but you'll notice that right there is that gap. So I have to stop it and say I have this gap at 1 and then going from 1 to infinity. If one of those were closed, I wouldn't have to stop it, but because it's not closed. Now, where is it negative? It is negative from negative infinity to negative 3. Then it's also negative at 1. That dot right there is 1. Now, how would you write it? You would just write it with those faces, brackets, whatever you want to call them, fancy brackets, saying that you also have that one piece at 1. Now, could you write it with brackets at 1? Yeah, you could. I wouldn't count that wrong. You could count it with brackets at 1. And that is the second part of day 2, technically.